So it's been a while. Let's take a few moments and recap where we're at. This unit deals so far with rational expressions. And we started off by learning that a rational expression is basically an algebraic fraction. It's a fraction that contains algebraic expressions in the numerator and denominator, and that if you want to simplify a single rational expression, you simplify it the way you would simplify a single fraction, which is to say you factor and cancel. When we are multiplying rational expressions, you basically factor and cancel. When you are dividing rational expressions, we use the rule that instead of dividing by a fraction, or instead of dividing by a rational expression, you multiply by the reciprocal and you turn it into multiplication of rational expressions, which is really just simplifying a rational expression. And everything that we had done up to Monday of last week, not including Tuesday or Wednesday, everything we had done was basically that, factor and cancel, factor and cancel. And there were non-permissible values thrown in there as well. But then on Tuesday of last week, we learned how to add or subtract rational expressions. So that's considerably different. In order to get our brains back into gear here, I'm going to do a couple of these. Although on this handout, number 1 doesn't say simplify, I am going to simplify C. We have 9 over x squared minus 36. And we are adding 3x over x minus 6. And in order for me to justify or explain or re-explain what's going on here, I'm going to just take a detour away from this for a second and say that if I had 7 quarters plus 3 eighths, I can't add those. And it's all in the language of how I say that. I have 7 quarters and 3 eighths. I cannot add quarters and eighths any more than I can add kittens and cheeseburgers. That just doesn't work. I have kittens and I have cheeseburgers. I can add cheeseburgers to cheeseburgers. I can add kittens to kittens, but I can't mix and match them, so to speak. So this is where the concept of a common denominator comes in. And in this particular example, now we'll stick with fourths and eighths. The lowest common denominator would be 8 because it has to contain a factor of 4 to include the first denominator, and it also has to contain a factor of 8 because it has to include the second denominator. Since 4 is included as a factor in 8, we don't need to do something silly like use 32. Some people will go, oh, 4 times 8 is 32. That's the common denominator. You don't do that. And you would multiply the top and the bottom of this by 2 to get 14 eighths plus 3 eighths. And then you can say, oh, well, that's 17 eighths. When it comes to numbers and we look at those original denominators of quarters and eighths, there's no need to write them in any other way. We look at them, we go, oh, the lowest common denominator is 8. It's obvious. Here, although it might be obvious to some of you, it's less obvious to most people. We have to factor everything completely. So I can factor the x squared minus 36 as x plus 6 multiplied by x minus 6. I'm going to be adding 3x over x minus 6, and now I can see what the common denominator is. The common denominator, in my example, let me get rid of this. The common denominator has to contain all of the factors in each denominator. So it has to contain x plus 6 and x minus 6 to take care of the first denominator. And that's, I like to say that's represented now. That denominator is represented in our common denominator. Now we go to the next denominator, x minus 6. Well, x minus 6 happens to already be represented there because it's included as part of the other denominator, just like the 4 was part of the 8. So now what you would do is say, since those are Since the first fraction is over that denominator, I don't need to do anything to it, but I do need to multiply the top and bottom of this by whatever is necessary to convert that denominator to the denominator I want, which is x plus 6, x minus 6. Now we can put them together, and we have 9 plus 3x times x plus 6, and this is over x plus 6, x minus 6. I know that it has been a while since we've been here together, but what am I going to do to the top that I'm not going to do to the bottom? I like that. Crunch it together. Simplify it by multiplication. Okay? And I'm not going to do that to the bottom because the hope is, and I don't know, I mean, this problem didn't even say to add them. It just asked about the common denominator. I don't know what's going to happen. But it could be that when we do that to the top, when we crunch the top together with multiplication, that we end up with something which is now factorable. And it could be that when we factor that result of multiplying out the top, that maybe there's a factor in the top that's a factor of the bottom. Maybe, maybe not. We'll see. So when I expand this out, I'm going to have 9 plus 3x squared plus 18x. This is over x plus 6 multiplied by x minus 6. All I've done there is multiplied through distribution that 3x in. I'm going to reorder this as 3x squared plus 18x plus 9. This is over x plus 6, x minus 6. Well, certainly we can factor a 3 out of the top. The question is, if we do, does it lead anywhere? Right? Well, let's find out. I take a 3 out of the numerator, and I'm left with x squared plus 6x plus 3. Well, it's a dead end, unfortunately, or fortunately. Because x squared plus 6x plus 3 is non-factorable, it doesn't go anywhere. Before I take questions from any of the work we've been doing with adding and subtracting, that's a basic summary, and you're going to have to be very careful with today's topic that you don't confuse what we're doing here with what we're going to be doing in today's topic. Today's topic also involves a lowest common denominator, but we do something different with it. Okay. Can you take a look at your work on this handout, please? Does anybody have, and I know it's been a few days, you might need a minute or two to collect your thoughts, but does anybody have any questions you would like me to go over from this extra practice sheet? Go ahead, Charlie. 7B. Ah, yes, good. Because I had gone through another example in class, and I think I had even mentioned I really should have these examples as part of the lesson. So I decided to, rather than just ignore it, I think it's important, I went through an example like this in class. And the basic idea here, everybody, is that this is what I call a complex fraction. And when I look at the big picture here, everybody, this is a single fraction indicated by that line. Okay. It has a numerator, and the numerator is this thing, and it has a denominator, which is that thing. So the big picture is it's a single fraction. But within the numerator, there is a denominator. In other words, it's a fraction of fractions. In the numerator, there's a fraction, and in the denominator, there's a fraction. And by the way, even if there's only a fraction in the numerator and the denominator doesn't have fractions in it, it's still a complex fraction. And what I like to talk about here, I'm going to actually rewrite this because I think many of you will understand that I don't like how the bottom of this is written. Okay? I don't like where that 4 is. So I'm going to write this as x over x minus 3. And this is over, and I draw that line really big to indicate that's the fraction. That's the big picture fraction. Over 4 minus x over x minus 3. And that way, whatever work I do here in terms of fractions, everybody, I can always visualize that 4 as being a fraction of 4 over 1. And I'm going to highlight the problem with this, the pests, the things that are getting in the way of us really cleaning things up are those things I've highlighted, those what I call mini denominators. So the best, most efficient way to get rid of them is to multiply the numerator and denominator of the entire fraction by that x minus 3. And this, by the way, is going to be something very similar to what we do today, but not quite the same. So what happens on the top, and I want to really make something clear here. You know me. Come on, get out of there. I like to talk about algebra, not just the content, okay? So yeah, we're dealing with simplifying a rational expression, but let's talk about algebra. I think it's important that you understand that the numerator is a monomial. It's one term. Whereas the denominator is a binomial. Okay? So when I multiply this x minus 3 across the top, I'm just going to multiply it by this whole thing because it's a monomial, and what's going to happen is the x minus 3's will cancel. So I'm left with x on the top, which is considerably simpler than what it was. So I'm left with x on the top. Now, when I multiply that x minus 3 across the bottom, I need to distribute, because that's a binomial, the multiplication. I need to multiply that by the 4 over the 1, and I need to multiply it by the x over the x minus 3. So what I get on the top, we're left with x, and on the bottom, I'm left with 4 times x minus 3, and then minus the x, because when I multiply that x minus 3 by the x over the x minus 3 on the bottom, those two x minus 3's cancel. But when I multiply the x minus 3 by the 4, nothing cancels. And I see that the proverbial light just went on there, and I think you probably could finish it. But I'm going to finish it with you. So I get x in the numerator. And look at this. This fraction, this rational expression is no longer complex. It's a single fraction. There's no fractions within it. I get x in the numerator over, I have to distribute that 4 by multiplying into the x minus 3, and then minus x. And I would probably say to you that I think there are a group of you that could go from there to there in one fell swoop. You don't necessarily need to write the 4 times the x minus 3. We want to simplify that a little bit more. 4x minus x in the denominator is 3x, so we're left with 3x minus 12. Are we okay to there, Charlie? Okay. That's actually fine as an answer, but only because if you do factor it, I'm going to stop. This that you're looking at, everybody, is a single rational expression, which you have to be able to simplify if it's allowable. You have to simplify it if you can. How do you simplify a rational expression? Factor and cancel. This is good enough for an answer because even though the bottom is factorable, nothing cancels. I can factor a 3 out of the denominator and write it as x over 3 times x minus 4. But since nothing cancels, I could have just left it alone. I would like you to get in the habit, though, of factoring and leaving it in factored form, even if it doesn't cancel, even if nothing cancels. just to drive the point home, these are the factors in the denominator. This is the only factor in the numerator. Nothing is identical in the top and the bottom. Is that okay, Charlie? Okay. Other questions? Go ahead.
Could you do the impermissible values for the question you have on the board?
Yes. For this exact same question? Okay. So this is a really good question that you're asking. And it crops up in Math 30-1 when we talk about trigonometric expressions. It's more complicated than some of us might think. Okay? It's a really good question. We have x over x minus 3, and this is over 4 minus x over x minus 3. And what I am going to do, everybody, is I am going to put a border around anything that's not allowed to be 0. Okay? Sure. This is not allowed to be 0. Because, everybody, and you need to follow this carefully, if that thing that I've just highlighted is 0, then the entire numerator of this fraction will not be defined. Because the numerator is x over that thing that I've highlighted. So that thing cannot be 0, because then the numerator would have x over 0, and the math gods slap you on the hand for that. You're not allowed to do that, right? Okay. By the same token, this is not allowed to be 0, but we've already kind of covered that, haven't we? There's something else that's not allowed to be 0. And the other thing that's not allowed to be 0, by the way, maybe I shouldn't just hand wave it away. This is not allowed to be 0 because then that piece of the denominator will not be defined. You'll end up with 4 in the denominator minus something that's not defined. The other thing that is not allowed to be 0, and I'll just use a different color here. The other thing that is not allowed to be 0 is this. Because if that's 0, the entire denominator is 0. So let me write out those two statements, and I can erase all this. We're done with this. One of the statements of non-permissibility, I've just made up that word, I don't know if it's a word, is x minus 3 is not allowed to be 0. That's like taking candy from a baby who's fast asleep. X is not allowed to be 3. The other statement of non-permissibility, I'm going to start using that phrase, is 4 minus x over x minus 3 is not allowed to be 0. And I really, as a teacher, and I'm being serious, this makes me really happy that this question has come up, because this is exactly what we're going to be looking at doing today. How do we solve this equation? I'm calling it an equation even though it's got the not equal to. Well, we look at it and we say, I don't like the appearance of it. There's something in it that I wish wasn't there. What is it you think I wish wasn't there? Christy, do you know? Right, because it's a denominator. Now, unlike what we did with this question initially when Charlie asked, we multiplied the top and the bottom by x minus 3 to get rid of those. I don't have a top and a bottom, but I have a left and a right. So I can multiply the left side of this equation and the right side of the equation by that denominator of x minus 3. On the right-hand side, 0 times x minus 3 is still 0. On the left side, that thing that I have in brown is a binomial. It's two terms being added or subtracted. So I have to multiply that x minus 3 by the 4. And some of this might look familiar, but please, let me finish here. And when I multiply the x minus 3 by the x over x minus 3, I get this. Some of this might look familiar, but do you remember when I said to you, what we're going to be doing today is very closely connected to what we're going over right now, but it's different? This is what I'm talking about. This is not what we were doing last week. This is something different. What we were doing last week was we were making everything over the same denominator. Here, we're getting rid of the denominators. Okay. Anyway, we can solve this now. What do we get? 4x minus 12 minus x is not allowed to be 0. That means 3x minus 12 is not allowed to be 0. I can add 12 to both sides and divide both sides by 3. X is not allowed to be 4. Now let's verify something here. What we've said is that x is not allowed to be 3 and x is not allowed to be 4. If I put x equals 3 in, if I put x equals 3 in, I get that, right? And that causes all kinds of problems because 3 minus 3 is 0. So right away on the top, right out of the gate, we have 3 over 0. Not allowed. That's why it's non-permissible. What if we, instead of putting 3 in for x, what if we put 4 in for x? Now let's see. What would the top of this be? The top of it would be 4 over 1. That's okay. That's 4. The bottom would be this 4 minus 4 over 1. Uh-oh. 4 over 1 is 4. 4 minus 4 is 0. Now we got a problem. Have I answered your question? Okay, so we have to look at the big picture here and not only identify many denominators as having non-permissible values for x, but the entire denominator would have non-permissible values for x. Before we move on today, any other questions you would like me to discuss with you or go over with you? Go ahead. 7C. 7C? Okay. That's this one that we're looking at right here? Okay. And again, I like when you guys ask me the right questions. This is a perfect question to ask to summarize everything that we've learned up to this point, particularly what we learned on that Wednesday before we took our super happy extra long weekend. See, in the previous question, I multiplied the top and the bottom by x minus 3, and that cleared the denominators. Here, let me rewrite this so I have a bit of room. I have 1 over 4 plus h minus 1 over 4 all over h. The problems here, the barriers to me working with this are those two denominators. If I want to get rid of them, then I'm going to have to multiply the top and the bottom by whatever is necessary to get rid of them. Okay? So, for example, if I look at the 4 plus h, I'm going to have to multiply the top and the bottom by 4 plus h. Great. But that doesn't get rid of the 4, does it? So I also have to multiply by 4. And I'm already in teaching mode for this next lesson. What I've said is I'm multiplying by whatever's needed to get rid of the denominators. But I want you to notice that what I'm really doing is multiplying by the lowest common denominator of all of those denominators, aren't I? The lowest common denominator of 4 and x plus 4 is 4 times x plus 4. H. I misspoke, but it's the same principle. So on the top, I have a binomial. I'm going to multiply both of these by that and by that. When I multiply both of them by the first term, the 4 plus h's will cancel, and I will only be left with the 4 minus, when I multiply these two factors by the 1/4, the 4's cancel, and I'm left with 4 plus h over the bottom, and just a couple of things before we finish this off and move on. I've just rewritten the bottom with the 4 out in front. Rather than having h times 4 plus h times 4, I just wrote 4h times 4 plus h. And I've also intentionally included an error in what I've written. And I really hope by the time you guys get to Math 30, you don't make this mistake. Some of you will, unfortunately, but I hope nobody does. What's the mistake? Brackets. That's a killer. If you don't put those brackets around things that you're subtracting, you will get an answer that's in the multiple choices. Or you'll get an answer that makes sense. So what I have left here, Ashira, is 4 minus 4, which is 0. And then I have minus an h. And the h's cancel. And I'm left with negative 1 over 4 times 4 plus h. And we're done. Okay. And clearly, if you look at that, negative 1 over 4 times 4 plus h, and you compare it to where we started, considerably simpler. All right, we are going to move on now.